Are you ready to teach class, Luna?
OMG, my AP Calc students, there you are. I was looking all over the place for you guys. Welcome back. Missed you so much. Anyways, let's do this example. This is from your Khan Academy. This is cavity and using the second derivative test. Let's just go over the second derivative test real quick. So, you take the derivative twice. That's why it's called the second derivative. If you get a value that's greater than 0, you say it's concave up. If you get a value that's less than 0, you say it's concave down. Pretty easy, right? Okay. I think the only difficult part about this is not the idea about concavity being concave up or concave down. It is actually just taking the derivative. And this is why you need to practice and know the chain rule, especially for your AP test coming up. The chain rule. All right, so here's an example. We got h of x equals negative 27 over the cube root of x minus 6. Okay? Breathe. It's not that bad. All right, first thing I'm going to do is get rid of this radical right here. So I'm going to turn it into, I'm going to bring it up to the numerator. Right? So it's going to be x minus 6. And instead of writing the third root, I'm going to put to the negative 1/3 power. Remember that? Sorry, my niece is having a good time. Now I'll use the chain rule on that. So I'm going to take the derivative of the outside. So I'm going to bring this over. So it's going to be negative 1/3 times negative 27. I'm going to leave this alone. I'm going to keep it as x minus 6. X minus 6. And then I'm going to subtract 1 from the power. So it's going to be minus 3 over 3, which is negative 4/3. Now, you have to multiply it by the derivative of x minus 6. What is the derivative of x minus 6? That is just 1. So I'm going to put just times 1. I don't really have to do anything, right? Okay. So that's my first derivative. No, I can simplify this. I can simplify it. I got negative 1/3 times negative 27. 3 goes into negative 27, negative 9 times. So I have negative 1 times negative 9. All right. So here's my first derivative. Oops. This is h prime of x. That is equal to negative 1 times negative 9. 9 times x minus 6 to the negative 4/3 power. I'm going to take my second derivative now. The same exact thing. Okay. The derivative of the outside, I'm going to multiply that right there. So it's going to be negative 4/3 times 9 times x minus 6. I'm going to subtract 3 over 3. So it's going to make it negative 7 over 3. And again, multiply it by the derivative of the inside, which is just 1 or uno. All right. Okay. Ooh, 3's cancel out. 3 goes into 9 3 times. So I got negative 4 times 3. My second derivative is going to be negative 12 times x minus 6 to the negative 7/3 power. Okay, so now I have my second derivative. I'm going to write it back in this form that was up here. So I'm going to put the radical back in it. So since it's negative, that brings this down to the denominator. And then I'm going to write it as a radical. So really, it's h double prime of x equals negative 12 over the cube root of x minus 6 to the 7th power. All right, so now I'm going to find points of interest. So these are important because points of interest tell us where there's possible inflection points. All right, so my points of interest are where this right here is either equal to 0 or undefined. So it's very similar to the critical points that we did for the when we're looking at intervals of increasing and decreasing and extremas. All right, so is this ever 0? Is the top part ever 0? Is negative 12 ever 0? Nope. So it's never 0. Let's see when it's undefined. It is undefined when this value right here is 6, because then we'll get 0 in the denominator. We cannot have that, right? So it's undefined at x equals negative 6. Okay, we're almost there, almost there, almost there. So I'm gonna make my number line, and negative 6 is my point of interest. Negative 6. So I'm gonna check a value to the left and a value to the right to see when is it concave up versus concave down. So it is, give me a number to the right. I think an easy number to check is 0, right? So if I check 0, I want to see if it's positive or negative, right? So I'm going to plug 0 into here. If I plug in 0, I get negative 12 over 3 times negative 6 to the 7th power. This is going to be negative. The cube root of a negative is negative. A negative over a negative is positive. So it's going to be positive over here. And I'm going to check the number over here, negative 7. When I plug in negative 7, you get you get negative 12 on top, so it's negative over a negative minus negative is a negative minus a negative. It's going to be negative. You're going to raise it to the 7th power. Since it's odd, it's still going to be negative. You take the cube root of a negative number, you're going to get a positive value down here. So it's going to be a negative over a positive, which is negative. So for negative 6 to infinity, it's going to be concave up. And from negative infinity to negative 6, it's going to be concave down. I hope that helps. I think the only tough part was taking the derivative twice, since it had the fractions as the what are those called? Exponents. Fractions as exponents. I hope that helped. Good recommendation, Jasmine. Bye.